Right, hello, I'm Noam, and as some of you might know, for the past couple of years, I've been working on trying to simulate the connectivity of coral reefs across Seychelles and the wider Western Indian Ocean. And the technical part of this project is now essentially complete, and I'm now working on data analysis, which is of interest to me for my PhD. But those questions that I'm trying to answer are not necessarily going to be the kind of questions that you're interested in as individuals involved in actually managing coral reef systems. So the reason why I'm making this video now is to is to basically share what I can do with these data and to hopefully obtain input from you as to what kind of output or product from these simulations would be useful for the problems that you're interested in, if anything. So I'm going to start off by by recapping what I've done, and then talk about the kind of questions that we can potentially answer um, with these simulations. If you've heard me talk about this before, you may have seen this animation here. So the basic aim of this project is to simulate the likelihood of larvae going from reef A to reef B, because that tells us about how closely connected coral reefs are. So to do that, because coral larvae are weak swimmers and they drift with ocean currents, we firstly have to predict what the ocean currents are doing. So we ran some simulations, and we now have these really nice high-resolution simulations of ocean currents in the southwestern Indian Ocean, which you can see here. And these data are imminently going to be available probably for free for anybody to download. And we've carried out validation, so we know these ocean current predictions do a good job of reproducing observations. So once we predicted the ocean currents, we're going to have to predict what the coral larvae were doing. So we carry out these virtual spawning events for all shallow water reefs in the southwestern Indian Ocean. We assume that our larvae are weak swimmers in the horizontal, which is a good approximation for coral larvae and potentially other larvae, but not all larvae. So for example, coral reef fish are often very strong swimmers. So for those, this wouldn't work, but for coral larvae, it works pretty well. And that these larvae are buoyant, so they remain at the ocean surface. And we then model the processes of larval competency acquisition and loss and also mortality. And we've used parameters from a paper for 5 particular coral species for now, but in theory, these parameters can be varied arbitrarily for whatever organism you want. So if you happen to have parameters for another coral species, we can work on that. But for the time being, we've used 5 example coral species, which I've listed here for these simulations. And then, although coral or broadcasting corals spawn at very particular points in the year, to make these predictions as generalizable as possible, we've carried out daily spawning events or daily virtual spawning events for the entire seasonal cycle. So basically, if you're interested in a organism that spawns at a particular point in the year, we can definitely generate predictions for that point in the year. So again, you may have seen this before, but this animation is just showing what we're actually simulating. So what you're seeing here is a stream of millions of virtual coral larvae streaming away from, in this case, a spawning event on Aldabra atoll. And as they're turning red, that represents the acquisition of competency of these coral larvae. And then they're reaching East Africa, and they're settling out at different reefs along East Africa. And they're also dying and losing competency. So this animation shows what the actual simulations look like. But in terms of the raw end product from these simulations, it's basically a prediction of how many larvae go from reef A to reef B as a function of time for all reefs in the region and for all days across 27 years. And this figure on the left just shows all of the coral reefs we've incorporated in the simulation. So this should hopefully be a really comprehensive overview of all coral reefs in the region. And on the right, we've just summarized these predictions in a connectivity matrix where kind of more yellowish colors show stronger connections from origin reefs to sink reefs. So this is an overview of the kind of top level predictions we've made. But in terms of more targeted questions you might be interested in, I've listed a few example questions here. These are not necessarily the questions you'll be interested in, but these are the kinds of questions we can really easily answer using these data. So the hard work's been done, and answering any of these questions is actually really straightforward from the data, from these raw data that I've generated already. So for example, maybe you're interested in corals at Cosmolido, and you want to know where are larvae from Cosmolido ending up, given that they spawn in, say, January. And we can predict really easily what are the most likely destinations, potentially, for corals or of a particular species spawning at Cosmolido or any other source location of interest. Or maybe rather than wanting to know where coral larvae end up, you want to know where they're coming from. So for example, maybe you're interested in what are the main non-local sources of larvae for reefs at Pralin. Or maybe you want to know when during the year larvae are most likely to be able to escape an island and reach other reefs. So one of these site-specific questions are really straightforward for us to answer, or we can answer kind of larger scale regional questions. So you might hypothesize that reefs that are more strongly connected might be more resilient to environmental damage, because if you've got a severe, say, marine heat wave that wipes out most of your corals on a particular reef, if you're strongly connected and you're receiving lots of larvae from other reefs, you've got a reasonable chance, maybe, of recovering. Whereas if you're a really weakly connected reef, you might struggle to recover because you're not receiving many larvae from other reefs, and therefore it's going to be much harder for corals to re-establish themselves in that location. So we can identify on whatever scale you're interested in which reef sites are potentially more strongly and more weakly connected. And we can also incorporate things like surface temperature into these vulnerability predictions. Or if you've got Reef A and Reef B, which are fairly distant, they might not be connected directly because coral larvae don't live forever, they've got a limited lifespan, but they might be strongly connected through an intermediate coral reef in the middle. And we call those stepping stone reefs. But if that stepping stone reef is then wiped out, that's then going to fragment the connectivity of reefs more regionally. So finding stepping stone reefs might potentially be interesting for your application if you're interested in understanding which reefs are important for maintaining regional reef resilience. And again, that's really straightforward for us to predict from these raw data. So these are examples of questions you might potentially be interested in. But again, I want to stress that the hard work's been done here. So if there are particular site-specific questions you're interested in, please do get in contact. I can't guarantee I can answer them, and obviously these are predictions based on models, not observations. But if we can answer the questions you're interested in, or if we can help to answer them, it's probably going to be really straightforward from my end. So please don't be worried about emailing to ask if these data can potentially help a problem you're interested in or contribute towards a wider problem you're interested in. So I'd really appreciate feedback from any of you as to what you might be interested in, but I want to finish off by talking about some stuff that I've been doing for the time being. So again, this is a connectivity matrix on the left that just generalizes or summarizes all of these connectivity predictions. But I've also been working on an online interactive platform with a colleague to make these data hopefully more accessible to people. So this is very much work in progress. As you'll probably notice, this is not Seychelles, this is the Western Pacific. This is just an example data set from a colleague, but I'm hoping to upload the Seychelles data really, really soon. And basically what you can do, what you can do on this website is you can visualize these connections geographically which makes it much easier, I think, to look at how strong connections are. So here, for example, in this data set here for deep sea vents, more red colours represent stronger connections between sites. And I'll do the exact same thing, but for the Western Indian Ocean and for coral reefs. And also you can mouse over particular sites of interest and you can get their name and you can get details about that site and you can find out about the particular connections for that particular site. So this will, at least for kind of basic connectivity data, I'm hoping that this website will make it really easy for those interested to get kind of top level connectivity data for any reef you're interested in a really straightforward manner without having to go via me, basically, or without having to interrogate a really complicated multidimensional connectivity matrix. So as I mentioned, this is a testing data set here, but really soon I'm hoping that this will cover my data from the Western Indian Ocean. So hopefully this will be useful when it becomes more finished soon. I've also been looking at the seasonal cycle of connectivity. So I've been looking at which reefs have a really strong seasonal cycle of connectivity. So, for example, preliminary tests have found out that some reefs in Tanzania have a really strong, predictable seasonal cycle of connectivity, whereas some other reefs, which tend to be the more remote reefs, have a really unpredictable stochastic variability of connectivity with time. And I'm also looking at basically larger scale network problems. So what I've done here is I have basically run an algorithm to look at clusters of reefs that retain coral larvae. So here, this algorithm has identified 3 clusters, and this, I should stress, this is not finalized peer-reviewed data yet, but from this particular run I've done, it's found 3 clusters of reefs, one which is East Africa and southwestern Madagascar, one which is Comoros and northern Madagascar, and one which is Seychelles plus Chagos. And these are basically clusters of reefs which tend to retain coral larvae. So coral larvae, coral larvae that are generated within Seychelles tend in general to remain within Seychelles, and we'd expect from these data that coral reefs within Seychelles are probably going to, and also potentially in Chagos, are going to be more similar to one another than to reefs in North Madagascar, or reefs in East Africa. And we can also do this at a final level. So although it's found these kind of top level clusters, it's also identified the cluster which is the southernmost outer islands of Seychelles, and the inner islands, and a different cluster which is the inner islands and the Amaranths, and a different cluster which is Chagos Archipelago. And then again, in East Africa, it's found these distinct clusters here. So if you're interested in potentially, reef similarity or comparing these to genetic data, like April's genetic data, this clustering might potentially be useful for that. And also the size of these dots here represents one metric for the resilience of a coral reef. So I won't go into detail about what exactly this is, but basically this metric is represents the number of coral larvae that are coming into a particular site, and it kind of favours coral larvae coming from different temperature regimes, because potentially larvae coming from different temperature regimes might be less likely to be affected by the same marine heat wave affecting a particular site. So just basically to summarise this, there are lots of kind of interesting networky things we can do to look at reef resilience. So thank you for listening, and just to kind of reiterate, main point here is that I can't guarantee these data will be useful for you. And obviously, again, these are simulations, which hopefully do reflect reality, but again, they're not observations. But if there are questions that you think these data could potentially be useful as a part of answering, please do contact me, and I'll be able to let you know really quickly whether this is something that we can help with, or whether the studies or the studies is kind of limited in terms of how much I can contribute towards. So thank you very much for listening, and I look forward to hearing from you.